Okay, the question is which of the following is dependent on temperature? Molality, mole fraction, or weight percent? Let's understand all of these individually. Now molality is represented by small m and it is moles of solute divided by kg of solvent. Now we all know what is solute. Solute is now suppose if we are talking in terms of sugar solution, sugar is solute. Once we put sugar in water and stir it well, it becomes a mixture. That mixture is called as solution. Alright, so what is solvent? Solvent is water in which we have dissolved sugar. Okay, so that's what is solute and solvent. So here in the example that I quoted, sugar is solute and the one in which we have dissolved sugar is solvent, that is water. Alright, clear? Okay, next thing that remains to understand is moles. Moles are represented by N. It is equal to mass of substance upon molar mass. It is mass of substance upon molar mass, that is number of moles. Alright. Now suppose if I say, we know that molar mass of water is 18. Alright. And suppose if I say I have given you 180 gram of water, I have provided you 180 gram of water. So what is the number of mole? In that case it would be mass is what? 180 gram divided by 18 is molar mass of water. So N would be equal to 10. Got to mention here that molar mass of water is 18 gram. And the water that we have taken is 18 gram. So when we are doing here, it is 180 gram divided by 18 gram. So gram gets cancelled. We get 10. 10 is just a number. Or it doesn't have any unit because it gets cancelled. So that's why we call it as number of moles. So it's just a number. Okay. So I hope this N is also clear. Alright, so that was about molality. Molality. Now let's talk about molarity. In case of molarity, it is again moles of solute divided by, now it is volume of solution in liter. Volume of solution in liter. Alright. And it is represented by capital M. Alright. So know the difference. Small m whenever we put in, it's molality. Capital M is molarity. Small m molality. Capital M molarity. In this case, moles of solute, same in both the cases. But in case of molality, it is kg of solvent, whereas here it is volume of solution. Alright. Okay. If you can guess, you have got the answer here itself. But then again, we will come to that little later. Now, what do we understand by mole fraction? Now, mole fraction normally is represented by this. Now, mole fraction means suppose there are two, like again as I told, sugar and water, right? Now suppose if I call A as sugar and B as water. So A as sugar and B as water. Alright. So then Na I represent it as moles of sugar and Nb is moles of water. Alright. So in sugar solution, we have Na moles of sugar and Nb moles of water. Fine. So what is mole fraction of, say, sugar? It would be Na, number of moles of sugar, divided by total number of moles. That is number of moles of sugar plus number of moles of water. Now if we talk in terms of mole fraction of water, then it would be number of moles of water divided by same Na plus Nb. Alright. Now there's something interesting about these two things. Now when you add mole fraction of sugar plus mole fraction of water, what do you end up? You end up with 1. Let's check it out. Now so it would be Na over Na plus Nb plus Nb over Na plus NB. Alright, so this would be equal to what? Numerator would be Na plus NB divided by Na plus NB, which would be equal to 1. We know there's another interesting, so XA plus XB is equal to 1. So if we have found out mole fraction of XB, then we just subtract XB from 1 to get XA, right? So we just take it there, so XA. So if you get one mole fraction of one component, the other component can be found out easily by just subtracting from 1. Fine. Okay. Now, so what is weight percent? Actually, weight percent we have been tackling it quite some time. All right. Even in your schools, you have tackled it. It is just mass of solute upon mass of solution into 100 gives us the weight percent. Now you have to keep in mind that unit of both has to be same. Now if you are taking it in gram, this also has to be gram. If this is in kg, this also has to be in kg. Fine. Okay. Now just to give you an idea, now see, suppose I have put 10 gram of sugar in say 90 gram of water. So what would it be in 100 gram? That's what is percentage, right? 100 grams of water. So it would be what? Unitary method. So it would be 100 into 10. We cross multiply this and divide by that 90. So that would what be the percent. All right. So it would be just cancel this off. Then this is 100 divided by 9. So 9 ones are 1, 1 1. So around 11% approximately it would come to. All right. Around say 11 approximately would come to around 11%. I hope this all concept is clear. Okay, fine. Now is the question, which of the following is dependent on temperature? Now tell me one thing. If I heat 1 kg of water and then cool it, would there be any change in weight? At the same time, if I heat 1 liter of water and then cool it, would there be any change in volume? Yes, in case of volume, there would be change. But in case of kg, there won't be any change. And what is it which is related with kg? Molality is related with kg. Alright, kg of solvent. So, which of the following is dependent on temperature? So, obviously, molality is not dependent on temperature. So, let's come to molarity. In case of molarity, it is volume. So, we know if we prepare a solution in hot condition and then if we cool it, obviously the volume would change. And since volume would change, then molarity also would be different. So, molarity is dependent on temperature. Alright. Mole fraction, again it is relative. So, no change. Here again, when we talk in terms of weight percentage also is weight. So, not at all dependent on temperature or not at all sensitive to temperature, but molarity is. In case of molarity, let me explain. I take 10 grams of sugar and dissolve it in 1 liter hot water. Alright. And then I cool it. When I cool it, what happens? Obviously, water expands when it is hot. So when I dissolved it in hot water, the volume of water was more. But as soon as I cool it, volume of water reduces. So what happens? So obviously moles of sugar would increase. Thus molarity would increase on cooling. Alright. But at the same time, if I take ambient water at ambient temperature, there won't be any change. Alright. So molarity is sensitive to temperature. So our answer is B.